Hi guys, and today we are starting a new series, an additional mathematics series. Now, the name of the series is Additional Maths Monopoly Madness. And what I'm going to use here is my Monopoly board that I had since I was a kid. And what I'm going to do a question for every block around the Monopoly board, right? So that will help us keep track and hopefully will make it a little fun. So without keeping you back too much with too much details, we are going to start with Go today, right? So our very first question will be Go. And our first question just happens to be an integration question. So before we actually get into the integration question, I just want to go through a few things with you all, that's some basics, right? I want to review angles quickly because it's going to be important in this question today. Okay? Never mind this little note on the side here. Now, when you're measuring angles, there are two ways to measure angles. You can measure angles with radians or you can measure angle with degrees. Now, 0 is 0 degrees in radians. Pi on 6 is really 30 degrees. Pi on 4 is really 45 degrees. I won't read out all, okay? But pi is 180 degrees. So you have to know this little table because sometimes you need radians and sometimes you need equivalent amount of degrees. So if you don't have it, take it down now, guys. I think you all know the procedure by now. The other thing I want to quickly review is how to integrate some basics. These are not all the formulas in integration, but it's mostly what we need for today. When you are integrating ax to the power n, by now you should know it's you add 1 to the power and divide by the new power. Whenever you integrate sine x, you get minus cos x plus c. You integrate cos x, you get sine x plus c. Cos ax is 1 on a sine ax plus c. Alright, now these are just some of the formulas. If you all are interested in learning all the formulas and go through a complete tutorial on integration, please go to YouTube. You're already on YouTube. In the search window, just type in the search box, is I love lessons, one word, don't forget this S, put a space and the name of the topic, integration. And I guarantee you the first video that comes up will be my integration video. It's 2 hours long, but it has every single thing you need to know in integration from the basics, and I gradually build you up to past paper questions. So look at that before you come here. So let's get to the official question that I want to do today. All right. So the question was to integrate 2x, well, the one wasn't here, 2x plus cos x between 0 and pi on 2. Alright, so I'm next to a very busy main road, so you're gonna hear some noise in the background. Sorry about that, guys. Okay, circumstances. When you integrate this, remember, x is really x to the power 1. So when I'm integrating, I added 1 to the power, so I got 2. And remember, you have to divide by the new power, which is 2. But there's a 2 waiting here. So the 2 and the 2 would cancel out to leave you with what? X squared. And when you integrate cos x, you get what? Sine x. So when you finish integrating, you're going to put back the limits, the 0 and the pi on 2. Now the reason I chose this particular question is because it has something that has tricked the students. Every question that I choose for this Monopoly Madness exercise always be a trick that students get wrong. Remember, things like sine, tan, and cosine are made for angles, okay? Whenever you see an x touching sine, tan, or cosine, an angle must go here. If the x is by itself, like over here, and it's not touching or connected to a sine, tan, or cosine, a normal regular value will go here. Let me explain. So you're seeing pi on 2 and 0. So this question has something to do with angles. Remember, pi on 2, let me look for it, is the same thing as how much degrees? 90 degrees, okay? It's the same exact thing as 90 degrees. So I kind of put it here to remind myself, pi on 2 is the radians and 90 degrees is the equivalent what? Degrees. 0 in radians and degrees is the same exact thing. Remember what we need to do from here? We have to take the top limit first and replace both x's with the top value, and then replace the two x's with the underneath value and minus both of them. However, when we are replacing this x with the top value, we have to put the degrees version. And when you're replacing this x here, you're going to put the radians version. You don't put 90 over here. It's pi on 2. And over here, when you're replacing the x's with 0, well, it doesn't matter if you replace it with the degrees or the radians. It's 0 in both cases. So, what's going to happen here? Right? We're going to work it out now. Pi on 2 squared, we replaced it. You're going to square the pi and the 2. So, pi squared on 4, because both of them get squared. And sine 90 is 1. If you don't believe me, sine 90 press equal is how much? 1. So over here, we get this expression for this brackets. This is this minus sign here. 0 squared is 0 and sine 0 is also 0. Sine 0 is still 0. So this whole brackets boils down to 0. So you end up with this minus 0, which is the same thing as what? If you minus 0 from something, you'll be left with the pi squared on 4 plus 1. Now, sometimes you will see this answer, and sometimes you will see this answer. I want to prove that this and this is the same thing. And that is where this came in. Right? Remember, pi squared on 4 plus 1. Remember, 1 is the same thing as 1 divided by 1. What I did, I found the LCM of 4 and 1. The LCM is 4. 4 into 4 is 1. 1 by pi squared is pi squared. 1 into 4 is 4. 1 into 4 is 4. Multiplied by 1 is 4. So this expression and this expression is the same exact thing. Alright guys, so this is one question that I really wanted to go through. I know students get problems with when they see the radians and they don't know whether to put the radians value or the degrees value inside the integration question, right? It's a common mistake. And guys, it's a gradual build up to add maths. These questions that I'm doing are just additional resources. You can't expect to watch me do all the questions here alone around the board and hope to pass the exam. No, these are just supplemental questions to help you. Because remember, a lot of you all are going, you're going to school. You have lessons. You have, this is extra work to go along with that, and respect the amount of work that it takes to build up from scratch to doing a question like this. So guys, please check out my integration video on the I Love Lessons channel. I guarantee you will not be disappointed. Okay, it's long, but it's worth it. Take care guys, and my next video we're going to be doing Mediterranean Avenue. Take care guys, and hope to see you soon.